This is part 2 of lesson 7-5. We're going to add, subtract, multiply, and divide radical expressions. So just to review some vocabulary with you, the number out in front of the radical sign is what we call the index. So if it's a cube root, a fourth root, a fifth root, that's the index. What's underneath the radical sign is called the radicand. So if you're adding radicals or subtracting, it's really adding and subtracting radicals, you have to have like radicals. Just like if you're adding or subtracting an x, they have to be like terms. So we have to have like radicals in order to add or subtract. What that means is both the index or the indices and the radicands are alike. So here's an example of some like radicals. 2 times the fourth root of 3a and 5 times the fourth root of 3a. The 4's have to match, the indices have to match, and so do the radicands. We have to have the same exact thing underneath. So the fourth root of 3a, the fourth root of 3a, I can combine these together. Well, how would you add or subtract these together? Well, just like when you're adding 2x plus 5x, you get 7x. When you're adding these, you simply add the coefficients of the numbers out in front. So you've got 7 times the fourth root of 3a. So this part will always stay the same, the fourth root of 3a. You just add 2 and 5 and get 7. These are unlike radicals down here because even though they both are cube roots, this one has a 5 as its radicand and this one has 5x. So they're not like radicals. This one is a square root of 3, this one's a fourth root of 3. You cannot add or subtract them together. So let's try an example. Now taking a look at this one, we've got 2 times the square root of 12 minus 3 times the square root of 27 plus 2 times the square root of 48. Even though they're all square roots, they don't have matching radicands. Not yet anyway. I've got a 12, a 27, and a 48. So the way it looks right now, we can't do any adding or subtracting. However, all of these happen to simplify or reduce. Let's think about the square root of 12 in this first one. I've got 2 times the square root of 12. Well, I know that the square root of 12 is the same as the square root of 4 times 3. That's helpful because the square root of 4 I can simplify. Let's move on to the next one. Then we have minus 3 times the square root of 27. Well, I know another perfect square that divides into 27 here, and that's 9. 9 times 3 is 27. Plus, then we have 2 times the square root of 48. I know a couple of perfect squares that go into 48. 4 goes into 48, but so does 16, and we want to pick the bigger one. 16 times 3 is 48. Now that I've split up each radical, I can simplify the perfect squares. For example, in this first one here, I've got 2 times the square root of 4 is 2. So 2 times 2 is 4, and I still have the square root of 3 behind it. That's the first piece. Then I've got a minus sign. Then I've got 3 times the square root of 9 is 3. So I can pull that out in front. 3 times 3 is 9. So I have a 9 square root 3 in the middle part. Then I've got plus 2 times the square root of 16. And the square root of 16 is 4. So 2 times 4 is 8. I've got 8 square root 3. Now I've got each one that has a square root of 3. Now the indices match and so do the radicands. So I can combine them together. How do you combine them? Well, you just use the number out in front. So I'm really going to combine 4 minus 9 plus 8, whatever that is, in front of the square root of 3. 4 minus 9 is negative 5. Negative 5 plus 8 is 3. So my answer is 3 square root 3. It's kind of amazing how you can combine all these together. Now, I don't want you using a calculator to do these because your calculator will give you a decimal approximation. We want to know the exact answer. So this is the only way to do it. Let's try multiplying. Let's try another operation. The problem I gave you here, we're really just using FOIL because I've got a binomial times a binomial, right? And there's some square root signs thrown in there, but don't let them throw you off here. Okay, so let's start by multiplying our first terms. 3 square root 5 times 2. Well, 2 is a whole number, so I got to multiply it with 3. 3 times 2 is 6, so I've got 6 square root 5. Then I'm going to multiply 3 square root 5 times the square root of 3. Well, that's positive, so I'll put a plus sign. 3 is your whole number that goes out in front. Then you're going to multiply the square roots. The square root of 5 times the square root of 3 is the square root of 15. Now let's move on and distribute the negative 2 times the square root of 3. Negative 2 times the square root of 3 times 2. I want to multiply the whole numbers here, and I get negative 4 square root of 3. Then you're going to take the last two terms multiplied together, negative 2 square root 3 times square root 3, and that gives us minus 2 times the square root of 9. I can multiply the square roots. Square root of 3 and square root of 3 is square root of 9. Okay, now can I simplify any of these radicals? The first one, no, I cannot. Second one, there's no perfect square that goes into 15, so I'll have to leave that one. Third one, cannot simplify it. And the fourth one I can. The square root of 9 is 3, so I'm really just doing 2 times 3, and that's minus 6. Now take a look at what you've got. Can I add or subtract any of these? The answer is no. I don't have any like radicals. They're all square roots, but they don't have matching radicands, a 5, a 15, and a 3. We cannot put those together, so our answer actually has 4 terms in it. Okay, one last thing to bring up here is conjugates. We've seen conjugates before with complex numbers, or I'm blanking on where else they show up, but kind of they show up almost in every chapter that we've done. So if you take a look at the conjugates of these radical numbers, you've got a square root of b plus c square root of d. The conjugate is a square root of b minus c square root of d. So the conjugate has a plus sign in one and a minus sign in the other, but otherwise the beginning two things will be the same and the last two things will be the same. We're going to use conjugates to rationalize the denominator. So here's an example of when you would want to rationalize the denominator. I'm dividing two radicals here, but I've got a radical left in the denominator, and we know that's a big no-no. So I need to rationalize the denominator. So how do I get rid of it? Well, I can't just multiply by the square root of 3 over the square root of 3. That doesn't work when you've got more than one term. Because I've got 5 plus the square root of 3, I need to use the conjugate 5 minus the square root of 3. And we're going to multiply top and bottom by the same thing, so that it's really just like we're multiplying by 1. All right, now put parentheses around these. We're going to go through that FOILing process or that distributing again. Okay, so starting with the numerator, I'm going to start with 1 times 5 gives me 5. Then I've got 1 times negative square root of 3, that's minus square root 3. Then I'm going to move on and distribute the second term, negative square root of 3 times 5. Well, I want the whole number first, so that's going to be minus 5 square root of 3. And then I'm going to take negative square root of 3 times negative square root of 3, and that's positive square root of 9, which we know is 3. Okay, in the denominator, let's do the same thing here. 5 times 5 is 25. 5 times negative square root of 3 is minus 5 square root of 3. 5 times the square root of 3 is positive 5 square root of 3. You can see why this rationalizes the denominator. Our square roots here will cancel out. And then you've got the square root of 3 times negative square root of 3, so that's minus square root of 9. Multiply those together. Okay, now let's do some simplifying. I'm seeing some things I can simplify here. The square root of 9 is just 3. So let me go ahead and simplify those. Positive 3 on the top and a minus 3 on the bottom. I'm seeing some like radicals here, square roots of 3's. These go together. So in the numerator, and sorry, also 5 and 3 go together. Those are like terms. So 5 and 3 gives me 8. And then combining these radicals, I have negative 1 minus 5. That's minus 6 square root 3. In the denominator, let's see what I can put together. Well, I know these cancel out, negative 5 square root 3 and positive 5 square root 3. And I changed the square root of 9 into a whole number 3. So I've got 25 minus 3. That gives me 22. Okay, so looking good here. I've got my numerator and denominator simplified. The last thing I'm noticing here is that I've got common factors. I've got a common factor of 2 in each term here. So I'm going to divide each one by 2. So my final answer is 4 minus 3 times the square root of 3 over 11. And that's how you rationalize the denominator. Okay, I've got one of each of these for you to try on your own to check for understanding. I know they're challenging, but you can go back and rewatch the first 3 examples and then try these on your own, please.